Okay, good. So hopefully you've now got the first slide up, and thanks very much for attending and welcome to this first presentation in the conference today. So I'm Simon Johnson. I'm Chief Technologist at CPI in the Electronics Business Unit, and we hope to get across to you today a little bit of an understanding of what we see going on in the flexible, hybrid, large area electronics arena at the moment in industry in the UK in particular. So as Chris mentioned, the title large area electronics has got lots of different interpretations, and we've used the title flexible hybrid electronics for this presentation. So the aim of the talk is really to give you two different perspectives. One is just to give you a bit of an update on some of the activities specifically at CPI and in our roll-to-roll capability, an area that is pretty unusual and is enhancing and developing all the time. But more importantly, we really want to try to give you an understanding of what we see going on in the flexible hybrid electronics industry in the UK and elsewhere as well. So focusing first of all on roll-to-roll flexible hybrid manufacture, one of the key things that we've seen recently is an increasing activity in other companies in taking up roll-to-roll assembly as a way of manufacturing flexible electronics. It's not a massive move. There are not thousands of companies doing this so far, but there are certainly a number of new companies starting to look at how to do this and indeed commissioning equipment and commissioning lines to do what are often very focused and specific sorts of assembly. You have heard us possibly talk about the roll-to-roll lines at CPI before, and the activity we have at CPI is very broad. We are able to do a wide range of different types of assembly with our manufacturing lines. But we're aware of a number of companies who are starting to do this, often in very focused ways. And the reason for mentioning this, I think, is to show that the flexible electronics industry is moving on. There are industry participants taking part and able to deliver assemblies in this sort of way. So that's a very interesting move that we've seen over the recent last 12 months, probably, I would say. At CPI, we've actually enhanced our own capability a fair bit over the last 12 months or so. In particular, we've added the capability of adding, picking and placing large area components, so batteries and supercapacitors, that type of thing, which really can be quite large, tens of millimeters on a side. And also we've added some new test capability to our assembly line. Both of these capabilities are still in development and in progress. But we hope to have those up and running over the next sort of 6 months or so. Another area that's developing quite rapidly at CPI in particular is roll-to-roll test. And we have a new standalone test equipment that we've been developing probably for 18 months or so now. It has very flexible capability, rather like the assembly line, and allows us to do various forms of test, right the way from simple resistance testing of printed circuits all the way through to complete mixed signal test of assembled circuits. The diagram here on the right hand side shows the standard flow for manufacturing of roll-to-roll flexible circuits. You print your conductor circuit, you then assemble components onto it, and most likely you then convert or singulate the final output into the final product. Well, alongside that, we've now got the capability of providing different forms of test at different stages. So the print, for example, which may be a simple silver circuit, or it may be a circuit with sensors printed on it, that could be tested and indeed characterized by this roll-to-roll line. We have the ability to characterize printed sensors and even to provide calibration data from those testing steps. That's an intention, not something we've got at the moment, but part of what we're developing. So we can test the bare substrate, but we can also then test the assembled circuits. And so after the component integration, the line can provide functional circuit test. Ultimately, this will be complete mixed signal testing and indeed device programming. And this is done through a stop-start sort of approach. So we have a test board with pogo pins that is applied to the circuit, potentially testing multiple circuits in parallel, anything from 1 to maybe 32 circuits in a single shot, depending very much on the complexity of the circuits that you're you're wanting to look at. But a very functional test, very similar to the sort of PCB test that is done on normal assembly lines. And the integration of the data throughout that process means that ultimately we can understand the yield and characterization data from devices, and also produce the data that's needed to understand which circuits are operational, which are within spec, and which can be used and sold at the next stage. So a very interesting architecture that's been established. And some pictures here just to show you roughly what this thing looks like. On the top left here, we've got the input stage where the roll of circuits is unwound into the test head, which sits just in the center here. That's where the pogo pins are applied. You see these images down the bottom here. You can see the pogo pins of the test board, small circuit in this case. The right-hand side diagram here shows the imaging and laser marking stage, so this can do optical inspection. There's also a stage that allows to do the wireless RFID type testing, so the NFC and ultimately UHF testing as well. And on the left here you see listed the current capability and the future capability actually that is currently in progress and will be developed over the next six months. So a very capable and interesting facility to allow for sort of roll-to-roll electronics testing of substrates right the way through to fully assembled circuits. So that's interesting work that's ongoing at CPI. But most importantly, we really wanted to try to get across some of the interesting developments we see going on in industry. We've been involved in a large number of projects over the last 12 months. Many of them very interesting, but unfortunately we're not allowed to tell you because some of these are commercially sensitive, of course. So we've selected a small number of projects here that hopefully give some idea of the breadth of activity that's going on. I'll get onto a few projects in a little more detail very shortly, but I just wanted to mention these two very briefly because they show the breadth, I suppose, of what industry is looking at in terms of the applications of flexible electronics currently. The first one I mentioned here is a Innovate UK project called Stevie, which is looking to do current sensing and imaging of current density on battery cells. We are seeing a lot of interest in the sensorizing, terrible word, sorry, of battery cells and trying to understand what's going on inside them, both during manufacture or shortly after assembly, and also in operation. This is a particularly interesting one that's looking to actually map currents around a battery cell, and to do so using a flux gate sensor, which is a rather smart little device. But trying to integrate flux gate sensors into a battery pouch is a serious challenge. So we've been looking at ways of manufacturing these devices and ways of creating arrays of them onto flexible substrates which form the battery pouch. And indeed, the output of the project has so far demonstrated the ability to create very high resolution patterned coil structures around permanent cores that allow the sensing of currents to pretty high resolution and interesting measurement approaches. The ultimate aim of that is to create arrays of these onto the pouch material, and then those are integrated into the batteries as the battery is assembled, an approach that's used in further projects that I'll mention very briefly later on. So from battery cells right the way through to spotting rats and mice in warehouses, I mean, this is a very interesting application that a rodent control company has been investigating for some time. In fact, they have an electronic system currently that helps them to optimize and improve their efficiency at checking traps and the like in buildings. But it's not the most effective. It uses PIR and sometimes it misses rodents as they're running around. So we've actually got to the point where we've developed a large area sensor that can be placed around the floor of a warehouse or similar sort of environment. And then that's electronically connected up to the cloud so that the rodent control guys can sit in their office and say, we've got some rats in a certain location, and off they go to deal with them instead of having to trail around in a very ineffective way. Very interesting, different, diverse applications, but genuine applications of large area or flexible electronics that the industry is looking at. Now we'll go into a bit more detail on a few more projects. although I'll run out pretty quickly, so I'll go fairly quickly through these. This is just illustrating, again, some applications of flexible electronics that industry is genuinely wanting to apply. The Fetching project is looking at producing a smart arena. This company, OptionsNet, based in Greece, have a product called SAMI that they're developing, and they wanted to enhance its capability to include flexible displays and flexible lighting hardware as part of the operation and functionality that they're able to provide. The flexibility was necessary because they wanted the areas where these things can be attached on marinas are really quite unconstrained, quite sometimes rather difficult to accommodate, and flat panels, fixed things really didn't quite work with the way that they're wanting to use the displays and the lighting. And so it was necessary to make use of these flexible technologies. And of course, flexible strip lighting isn't something new. We don't claim to have invented that. That's something you can buy off the shelf as a commodity item now. But the extension of that into large area panels, and indeed the panels we produced were fairly small, as you can see here, something like 30 centimeters square, but those could easily be extended, and the application had a desire to extend them to larger areas. And so again, a company that is looking to make use of these technologies in real applications. And just to enhance that feature, really, the whole system was connected up into a communications network that allowed data to be transferred down to the displays to configure them and so on, and also things like presence data to be uploaded from the region, so that the operators could know when boats had arrived, when berths were empty, and this type of thing. And this is very standard technology, nothing flexible at all in this. But the reason for mentioning it again is to try to get across the fact that companies are using flexible electronics in the way that we use the rest of electronics now, the sort of PCB systems. Some areas, flexible electronics works, and then it's just integrated into a conventional electronic system. And the final image is here, rather nice, showing the use of these displays in a system that's been installed as a demonstrator in Greece. I didn't get to go on the install, which I was rather upset by, but it has been demonstrated to be a very effective way of doing this. POETICS is a very different form of project that we've been undertaking with an organisation, a small company rather, called Reelables. Reelables have a very nice concept for an asset tracking label, a sticky label that is on a reel. Genuinely, you can cut it off and you've got an electronic asset tagger or tracker that can tell an operator, maybe somebody who hires out equipment, this type of thing, where different items are. And they've got a proven product, but what they're trying to do is improve the form factor in particular. And the serious challenge that they had was based around the power source for these. They are active labels, and so they required a battery and power source. And integration of the battery was a challenge in the manufacturing process. So we've been helping them understand the options for producing a battery on flex, to actually print the battery directly onto the substrate that the circuit is manufactured on. And we've been looking at the use of lithium battery technologies for this and chemistries, and have introduced some new processing steps, particularly the ALD coating of the lithium after deposition to protect it and allow processing in oxygen atmospheres rather than in nitrogen boxes and the like. So enhancing the manufacturing process. Pretty good performance by the battery. The graph on the right here shows the evaporated lithium device that was produced through this process compared to a commercial device on the left. And we're getting reasonable battery capacity out of this, something like 10 milliamp hours currently. That needs to be increased a bit more to make a practical battery for this particular application. But again, a genuine application where a company is needing to use this flexible electronics approach, and there are some interesting challenges that are being solved as we go through these different projects. And then the final one I want to illustrate in a little bit more detail was a project called Vehicle. Vehicle is an aim, it's based around a technology that a company called Design LED, who currently have 2D planar lighting technology. It's a very smart idea. Lighting panels, of course, are all over the place, but they're generally quite thick. To get a nice uniform, homogeneous sort of lighting effect, you normally have to separate off a diffuser by quite a spacing. Normally, the spacing of the LEDs in your panel is roughly what you need for the spacing of the diffuser. So you get quite large, thick panels. Design LED have a technology making use of light scattering and different materials that means they can create very thin planar lighting panels. And it's a very smart technology. It's already established. It's a flexible printed electronics solution, in fact, which is a rather good illustration. But what they wanted to do is take it to the next step and create 3D parts. And so the aim was to try to apply their technology to thermoformed circuits, so parts that could then, say, go in the interior of a car, and your armrest in your car glows nicely in a particular color when you arrive, and things like this that are very important for the automotive industry. The slide here, I'm not going to dwell on it all, but just to show you the complexity of this interesting challenge that we were hoping to develop with them. The project involved Dagtech Materials to develop some new flexible and stretchable links. Very interesting developments, and now some commercial links come out of that work. We worked on the assembly processes that are used to create the circuits on polycarbonate substrates that are then thermoformed. And Design LED did the smart bit of the light distribution. The image you see on the bottom right there, you can see in the background a sort of shading that goes on. That's the light scattering activity that is cleverly designed by Design LED to create these uniform lighting panels. And yeah, we had some very nice working demonstrators out of this. These are not these don't include the distribution lighting technology incomplete here, but they show the assembled circuits, the 3D formed circuits involving touch control and things like this. So yeah, certainly demonstrated that a technology can be, these technologies can be used to form the sort of parts that Design LED would then be able to apply their technology to create this uniform lighting device in a 3D form. So those are existing projects or projects that are recently finished. We've got some very exciting new projects coming along. And the key thing really, I think, is to get across that industry really is engaging with flexible electronics. There are lots of interesting applications from rats to improving battery performance. And the areas of technology, of the application of this technology rather, are very diverse. And industry really is taking this up. We're finding demand for high volume of products, so requests for 100,000 of devices are not uncommon. And there really is an interest and a desire to make use of these technologies for enhancing the functionality and capability of different devices in a wide range of application areas. I won't go through all of these three, but as you can see, more applications and more interesting use of flexible electronics is on the way. So I'll stop there so that I don't overrun, rather short at the end there. If there are any questions either now or do please get in touch. We'd be very happy to talk and explain more about these applications.